Welcome to my Switching, Routing, and Wireless Essentials course. This should be the CCNA version 7 curriculum. This is the second of 3 courses. Moving on, we have a Configure Switch Port Access. This is going to be setting up more of the port functionality. Like duplex. By default, full duplex allows communication simultaneously to be sent and received. This is bidirectional. You can actually set half duplex so you can either be sending or receiving. This is unidirectional, and realistically this is not done. It should be left at full duplex, and that allows for full functionality. Moving on is speed. You can actually set the port speed. By default, port speed is set to auto. So if you have a 10100 device plugged into a port, the port will negotiate the highest speed. You can manually set it to a speed. However, if you manually set it and you plug in a device that is not currently that speed, that port will not turn on. Realistically, modern day networks, most things are gigabits. Leaving an auto is not a terrible issue, and you see it more common than not. It's important to note if we're talking fiber has to be manually set and will operate only at one preset speed and always full duplex. Alright, with that, let's move on to configuring a switch port. If you want to configure the speed manually, you would log into the device, go to the appropriate interface, set up duplex mode, half or full, and then you could set speed. The speed would be in megabits what you'd want, end it, save it, restart it, and the device will now operate at that speed. Again, realistically, leaving it auto is typically done. Auto MDXI, this is always a fun one. Not all devices support or have auto MDX. I will keep saying MDXI. It's a bad habit. I apologize. In previous videos I talked about this, but basically what the auto MDIX does is it will recognize what type of cable is needed and will apply it. What I mean by that is when you hook up 2 switches, in order for 2 switches to communicate, they should have a crossover cable between them. However, if auto MDIX is turned on and functioning, if you accidentally use a straight through cable, then the switch will then auto flip the ports internally, so a straight cable will work. You cannot assume that all devices have auto MDIX. So again, when wiring up a device, always make sure to use the appropriate cable. Like devices, switch to switch, use a crossover. Router to router, use a crossover. Any uncommon devices, PC to switch, use a straight through. Understanding cabling types is very important. Alright, moving on. Verifying commands. Things like show run, show start, show flash, version, history, show IP interface. You can actually look at detailed information on an interface. Show IP interface brief will give you a brief view of it. Knowing how to navigate show commands is pretty important, and we'll actually talk more later in the training series about using show commands more effectively in troubleshooting. Next, let's talk about verifying switch port configuration. If we do a show run, we can actually look at the running configuration of the device. Here we're looking at a show run tailoring to the VLAN interface and the IP default gateway address. Basically, we're just verifying this piece of information. If we do a show interface and we actually list out an interface, you will actually see a detailed breakdown of the interface. Is it up? Is the line protocol turned on? What MAC address it has? What the MPU is? What the bandwidth is? What the delay is? The reliability, the sending load, and the receiving load. Those are big ones. If it's full duplex, half duplex, is it set to operate at gigabit or whatnot? The big things here actually, bandwidth, reliability is a big one, and the sending and receiving loads, those are important. Realistically, as we get into troubleshooting and we start looking at network congestedness, this is where we're looking at to see if a port is able to handle what is being sent and received. We actually look more at that in a later video, but I wanted to point that out just to show. The output from the show interface command, again, we're looking at media issues. If it is turned on, you should see the interface is turned up and the line protocol is turned up. If it is turned off, you should see that it is in a shutdown state. One thing that I do like to point out is if the interface is up but the line protocol is down, it's typically an encapsulation mismatch. So if you're setting up encapsulation, again, we talk about that in a later video, it may actually be mismatched. Again, whatever we do on one side of a wire, we want to do it the same on the other side to make sure that our protocols are set up on both. Again, if it is in a administratively down state, it's because we issued a shutdown command. So let's look at the show interface a little bit more in depth. We can actually look at things like runts and giants and errors and CRC issues and things of that nature. You can also look at collisions and output errors and late collisions. What do those mean? Realistically, as you move through the Cisco curriculum, the higher level courses, understanding the show output or the show command output becomes important. Understanding things like runts and giants help you to troubleshoot what's going on. Those error types are, if we're looking at an input error, that will be the total number of errors, including all runts, giants, buffers, everything. If we're looking at just a runt, that will be a packet that are discarded because they are smaller than the minimum packet size. The minimum packet size is typically 64 bytes. That's a runt. If we're looking at a giant is anything above 15, 18 bytes. Yes, I understand that we can have jumbo frames that will be above 1,518 bytes, but that's outside the normal content for what we're covering. We have a CRC error. Those will be how many CRC errors are generated when the calculated checksums are not the same as what's received. Output errors are the sum of all errors that prevent the final transmission of a datagram, whether it be a frame, typically a frame because we're dealing with switches, that is being examined. Collisions are the number of messages retransmitted because of a collision. And a late collision is a collision that occurs after the first 512 bits of a frame. Realistically, this is good stuff to know, and if you're troubleshooting, these are good things to know for layer 1 and layer 2, but these are things that you normally will not memorize. You need to be able to look them up where they're at. Moving on, we have our runt frames, which we've already talked. If they're smaller than the 64 minimum allowed, giants are larger, unless jumbo frames are enabled. CRC errors are one of the big ones because we'll actually do a CRC checksum to verify if a frame is accurate. Collision and late collisions we've already talked about. Again, late collisions after the first 512 bits are sent. If we are looking at how to troubleshoot layer 2, the network access layer. Can you see the interface? Is the interface up or down? If the interface is up, then is there an issue with the layer 1 media? Issue with the duplex? Issue with the speed? If the interface is not up, we check the cable, we check the connectors, we check the speed on both sides of the cable. And then if we're looking at if that fixed the issue, if yes, great. If no, then we escalate the issue. One thing that I don't see here at all is the interface up? Did we verify that we turned on the interface? I always find that people will configure devices and forget to turn on the interface. So, is the interface up? Was the no shutdown command issued? Then follow the flowchart. That would make the most sense. Questions, concerns, please reach out. Thank you.